Hi, this video is going to go over the build of an Eggtimer RX module. The RX module is a fairly simple build. It is designed to connect to a Windows laptop computer and track your data coming from a Eggtimer tracker like the Mini TX or the TX or a Quasar in real time and display that data on your laptop. You can use a program like MapSphere or something like that to track your rocket in real time. This is my setup. I use a Hakko FX972. Not a really difficult build here. You don't really need anything like this, but having a soldering station really helps. And in this case, I would think that a regular kind of soldering stick type of setup would work just fine. Just make sure you have proper ventilation or a fume extractor. And I do like to use a vise or something similar to hold your work. So let's open up the package. Like I said, not a lot of components in this one. Now I'm going to make a couple changes to the way the instructions recommend building this. One main one is the instructions recommend soldering your cable, your serial cable, straight to the board. I don't like that because I like to be able to disconnect it. So we're going to use a couple extra headers, and it comes with a stick antenna that you'll see that I'm not really going to use either. I'd rather use a connector and be able to take the antenna off. So we'll go over those changes as we go through the build. But for now, get all of your components out of the anti-static bag. Now, here's the discrepancy. On the packaging, it said Rev C2, and on the inventory sheet, it said Rev C2. But when you look at the PCB, it says that this is a Rev C5. So we're doing the Rev C5. I'm not quite sure why the instructions in the packaging say C2, but this is a Rev C5 build. So put your PCB to the side, and then we're going to inventory everything here. This is the RF module. Not too difficult to figure out what this is. It's the only large chip package on the board or in the inventory. Next up, you'll get the voltage regulator. Again, pretty standard on most of these builds. Not a lot of components to solder on this board, so actually pretty quick build. So next up, you'll have an LED. Mine was red. And there's a through-hole LED. Next component you'll get is some resistors. There's only one resistor, so it's a 2.2K resistor. You're going to need one of these. You get two, you get an extra one. And then you're going to get a couple capacitors. There's only one kind of capacitor in this build. Again, you can't mess them up. But these are 10 UF capacitors coming in a clear plastic carrier. And this one you only get two, and you need two, so you can't lose one of those. They are easy to lose, so be careful. You're gonna get you get some of these headers. Like I said, I'm gonna need an extra one here just because I don't want to solder my serial cable right to the board. But I'll show you that later, and we're gonna have to cut those up. Here's the antenna that comes with the package. It's a stick antenna with some heat shrink. I'll show you where that goes, but we're not going to use that. We're going to use a RPMSA connector. And then you do get some components like the serial cable. If you buy this USB option, which I did, I don't really like the Bluetooth option. It's not as easy, and the serial cable always works as long as you're using the right version of Windows. You get a jumper here for when you need to program the frequency on the board, which you'll need to do. And then finally you get some soldering cable, soldering wire from Eggtimer, which is really great stuff. This is Kester stuff that's awesome. Highly recommend using that if you don't have your own that's equivalent in quality. And then finally, like I said, I'm going to add a couple components here. I'm going to use some headers that I have. And since I'm going to be using an RPSMA antenna, I'm using an RPMSA connector that I got from Eggtimer at one point. So you need to add those if that's what you're going to do. Like I said, I like to use a pan of ice. It just is so much easier when you're soldering PCBs like this, small PCBs. to have a pan of ice like this to hold your work as you're soldering. In addition to that, you should have some tweezers. I like to have at least a pair of pointy ones and a pair of flat ones on hand as you're going through the work. Those are the basic equipment here, and the first component up is the voltage regulator. So that goes in that space right there with the 3 small pins and the 1 large pin. So what you're going to do here is tin the large pad and then move the voltage regulator into place. Now it needs to be centered on all 4 pads, both left and right, and to make sure that those small pins are kind of right in the middle of the small pads. So kind of hold that in place, let it cool. Now when you go to solder these small pins, you have to make sure you wait 30 seconds in between each solder. I'm not going to do that on the video. I cut that portion out so you don't have to sit here and look at nothing. But when you do, I did wait the 30 seconds. Please do that as well so you don't overheat the chip. Now when you solder these pins, you just you heat up the pin in the pad and get your solder to flow underneath the pin and over it in a nice tent, but don't bridge and don't get all the way up on the plastic portion of the chip. Once you're done with that, heat up that large pin again and get a nice chunk of solder on there. Now here's the capacitors. We're going to put them both in. They say 10 UF silk screened onto the board there. So they go kind of right around the voltage regulator. Now to put these surface mounted chips onto the board, what you do is tin one of the pads and then move the component into place and make sure it's centered on both pads. And then once you have the component in place, take your heat off and it'll stay tacked in place. Now go and solder the other side, and you want to make sure your solder flows up under the chip again and over it in a nice little tent, but you don't want to bridge anything underneath or to another component. So not so much that you get a bridging effect or with any of the other pins or the other side of the chip, but enough that it's gonna hold on there, because these are flying around in a rocket. So make sure you have enough solder on there so they're securely held in place. So those are with the capacitor. This is the only other surface mounted component you have. It's that resistor, the 2.2K resistor that goes down there in the spot marked 222. Same exact way you did the capacitors. Tin one side, move the resistor into place, centered on both pads. And you notice I'm turning the board. That's one of the reasons I like the vise, because it makes it very easy to turn it to best orient for your soldering. But this is the LED. Now it is polarized. See how it has that longer pin on one side? That longer pin is the positive side. It goes into this hole marked with the plus sign. So make sure you get this right, or the LED won't light when you go to use your board. So all you do is just drop it in the hole with the long pin towards the plus side, tape it down, and then turn it over and solder the 2 pins in. This is a pretty simple through-hole soldering, but make sure you get a decent amount of solder. It has to kind of get into that hole and seat down in there, but also have a nice little tent of solder that's nice and shiny so you don't have a cold solder, but not so much that you have a giant mound of it. And then you're going to clip off the excess pins. Keep these, they're great for bridge pins, but also make sure you control them with something so they don't go flying. Now the RF module lines up so that all those 7 pins along the edge are lined up, and the 2 pins where the antenna side is line up with their pads. Tape it down and make sure you have the right orientation. You can see I put a pin in on the lower left-hand corner there through the hole. That can help you orient the board and make sure you've got everything right. Once you have it taped on, take that pin out if you used one, and then tape the entire board after this so that all of those components, all of those little tiny chips that are soldered on there, those surface mounted chips on the RF module, are all covered. So that way, if there's any spalling with the soldering that you're about to do, it doesn't get up on the chip and ruin something or bridge something on there. Now, similarly to the voltage regulator, you want to wait 30 seconds between each one of these solders. Okay, do not do it right in a row or you could overheat the RF module. But once you're ready to solder each pad, go ahead and you're going to heat up right into that kind of notch there and put a little bit of solder in, and you want the solder to just get inside that notch, but not cover the board. Now, I did one on one side, and I'm going to do these 2 near the antenna side waiting 30 seconds in between each one. This really tacks your board down nicely so it won't move. That way, there's no possibility that your board is going to move while you're trying to do all of these solders. But once you're done, wait 30 seconds between each one, and then just go ahead and do each one. And once again, just a little bit of solder that gets up underneath the board slightly, and then into that notch, but not all the way over. If you've got enough solder that you're covering the hole on the top of the RF module, you've definitely used too much. So they should look pretty much just like this: a nice, neat tent of solder with a shiny tent of solder across each one of these notches and pads on the RF module. Okay, when you get those done, we're going to have to deal with the antenna situation. Now, like I said, this is the stick antenna that comes with it. And in the instructions, you're going to bend one end down so it goes into the hole on the board, and then solder this all the way onto the pad, and then cut it to the right length because it's frequency dependent. We're not going to do that. But that, once you've soldered that in, you put the heat shrink tubing on and shrink that onto the antenna. If that's what you're going to do, that's the procedure you'd have to follow. We're going to use an RPMSA connector, which has 3 pins on the top and 2 pins on the bottom, as you can see here. And what you do is you're just going to slip it right onto the board, onto all 3 of those pads. So those top 3 pins rest neatly in the center of those top 3 pads. And then once you have it on, just turn it over and tape it in place so it's nice and secure and it's not going to move, just like that. And then we're going to have to solder those top pins on first. If you have a thicker solder, use the stuff that came with it if that's all you have. But I use a slightly larger tip here. I turn up the heat just slightly, about another 10 or 20 degrees, and I use a little larger diameter soldering wire here because you do have to get quite a bit of solder on here. And using thin solder and a smaller iron it takes a little longer. It's harder to heat up those large pins on the antenna. But whatever you're doing, that's the procedure. Heat up the pad and the pin. In the center one there, you're going to have to heat up that whole that round pin and the pad and get enough solder on it to kind of go over it like that, because that's kind of the key here. Not only are you creating a good connection for your antenna for the signal that's going to go through, but this solder is holding on. It gets a lot of torque, right? Because you're going to put a long antenna on top, screwed in, so it's always getting a lot of torque when you're screwing on the antenna. Plus, you've got this antenna sticking out that has a tendency to get bumped around and could rip this connector right off the board. So make sure you've got a pretty decent amount of solder holding the antenna on. And at this point, once we get this antenna connector soldered on, you're done with most of the components now. The only thing that we're going to have to do after this is the headers, and you're going to have to cut up the headers. So this is what one of the header block that it comes with, and you're going to want to cut this up. Just use a pair of like wire cutters or whatever and clip them into different sections. You're gonna need a 4, a 3, a 2, and then if you're going to solder in where you would connect the serial cable, then you're gonna need a few of the singles as well. And I'll show you where all of these go on the board if you're gonna do it that way. I personally like to have the cable connections connected by a header, so I can remove the cable. I don't want to waste an entire serial cable just for one board. So once you have a bunch of these, and if that's the case, you're going to need some extras that don't come with the kit. So the 4 pin header goes right on the top there where it says RxD, TXD, GND 3v3. The 2 goes into the program block there, and make sure you're putting the short side of the header into the board. The long pin sticks up. 1 goes into that receiver mode there, and then the 3 goes down there. That's where you're going to connect if you need to program. And then the 2 singles go down there for when you're going to power it, where the power cable from your serial cable would go. So get them all in place, and then just tape them all down, all at one time. I like to just push the tape right through the pins, or push the pins right through the tape. Apologies, the way around. And then that makes them stay nice and flat against the board and keeps them all nice and secure when you turn the board over. But once you have all the headers tape down, this is a pretty simple through-hole soldering exercise afterwards. Turn the board over, and then just solder each pin with a nice tent of solder, a nice shiny tent. Make sure it's down seated in the hole, and securely solders each pin in, so you don't rip one of those headers out when you're connecting and disconnecting cables. But other than that, this is pretty simple, and this is pretty much it for the build part of the board. You can probably knock this whole board out in 10-15 minutes if you're familiar with it. So we're going to test everything now, and what you're going to do with the serial cable, assuming this is the version you have, is connect the red and black wires, the ground and positive wires, to your negative. The red goes to the positive, the plus sign on the power cable there, or power block, and then the black goes to the negative on the power section there of the board, and then the white cable goes to that middle single pin for the receiving pin, and the green one is not used in this case. But when you've gotten that done, you can see where the cables are connected to here. If you didn't solder it straight to the board, which I did not, we're going to just plug it into a USB port on your computer, and that red light should light up. Oh, sorry. You first connect an antenna so you can get a transmission from your transmitter. And when you plug it in, you should get the red light up like that. That's what should happen. Now, if you're receiving from a transmitter, you're also, the green light on your RF module will start to blink. If everything is good, then go into, I'm going to use PuTTY here to check this out. In my case, it was connected to the COM4 point on my Windows computer. And this is the output you should be getting in something like PuTTY if you connect it to a terminal program like this. This shows, so right now it's also connected to a TX transmitter that's transmitting data. So this is the kind of output you should be seeing on your PuTTY window. And if you check it with like a program like this is Visual GPS in Windows, you can see that we have 6 satellites, 4 tracked. You're getting a lat long. Scatter plot works. You can look through this and see, making sure that everything's coming in properly. I did not check this with MapSphere, but and you can also check the NMEA data directly in Visual GPS. Great free program to make sure your unit's working properly. But this is what you should see if you built everything properly and it's connected properly. So that's it. It's like I said, a pretty simple build. It's pretty quick. And as they note on the website, Eggfinder does say you probably shouldn't use this as your primary means of tracking because it's difficult to walk around with your laptop if you're out there, in the field trying to actually look for a rocket. However, it's kind of really cool to have this available, back at your table, back at your campsite there, so to speak, in a rocket launch, and be able to kind of map this on your laptop. And it's also great for tracking all that data and recording that data if you want to record it. So, if that's the niche kind of case you need, then this module is something you would want to get and build and attach to your laptop. So pretty simple. And hopefully that you don't have any issues, but if you do, go ahead and throw your questions or comments down in the comment section. And thanks a lot.